everyone, welcome to my talk on the topic of going global with serverless, or how to build global services with serverless. My name is Darko, and today we're going to be discussing how can you actually make a highly available, reliable, and globally scalable application on AWS with the help of some serverless services. Before we get into anything, let's actually look at some fundamentals. Let's talk fundamentals, the important things, right? The first question of the day is, what is reliability? Well, reliability is the ability of a service, a workload, an application to actually recover from service disruptions, has the ability to dynamically add new resources or scale, and also has the ability to mitigate disruptions. Some things like, for example, transient network issues, misconfigurations, and those similar things. The other question is, what is availability? What is the first thing that comes to your mind when you think, availability? Let's look at Wikipedia. Wikipedia says it's basically the degree through which a system, a workload, an application, equipment, whatever you run, is available to operate since the beginning of its operation. So this is where we define those 99.99999% uptime. So you most likely have heard all of those things, but that's the availability part. And let's actually look at those numbers, because it's very important to understand, to at least get the perspective on what is this availability by the numbers. So looking at those nines of availability, this is a really nice tabular representation of how many nines require how many minutes of downtime per year, or actually maximum downtime per year. If we go just to 90%, that's 2.5 hours per day downtime. I hope you don't have a critical system that's 90% uptime, 90% available. But if you go all the way to like 99.999, that is 5 nines of availability, you can have 0.86 seconds of availability per day, or actually downtime per day, which is 5.5 minutes per year. So if we look at some graph along with this, we actually see this. As we reach the higher number of nines, the less and less time we can have available to actually do something, or actually to put in a system not being available, right? So how can we increase the availability of a given system if, for example, our system is 99% available? We add another one. By actually adding things in parallel, we can increase the availability of the system. So in this example, if we have part X and part Y, well, actually both let's say part X is 99% available. If we add another part X in parallel to this, and according to this lovely function here, we actually get 99.99 availability. Hence, it looks something like this. So by actually having 2 X's in parallel, we have it 99.99. Having 3 gives us 6 nines. So the more things we add in parallel, the more availability we have. There's just one problem. By increasing component redundancy, also increases, well, this is not a problem. I'm going to reach to the problem. I misspoke about the slide. But yes, component redundancy, having more components available to serve your application, to serve your workload, increases its availability significantly, as you've seen from my example. Speaking of which, who is this bald person and why is he screaming at the camera, you may be wondering? Well, my name is Darko Meszaros. I'm a developer advocate at AWS. I am working for AWS for almost 5 years right now. I'm based in Berlin, Germany, but I'm originally from Serbia, hence the different types of spellings you see all there. I've started in AWS in premium support, so I've worked with just supporting folks like yourselves, having problems with AWS, to move into solution architecture, where I supported customers who actually were building things on AWS. And now I support all the AWS community in Central and Eastern Europe, where I talk to you, the lovely engineers, the lovely community members, the folks who build things on AWS, and try to, well, help you do it a bit better. If you want more of this, if you want to hear more of me after you listen to my talk right now, make sure to check me out on the social medias and the YouTubes and all the stuff. I do a lot of content there. So if you want to see more, check it out. Let's have a look at one important slide. This one. Now, take a moment. I'll have a sip of coffee and take a moment and see what this is. Exactly. That's a lot of regions. AWS has 24 regions, 77 availability zones, and over 220 points of presence across the globe. So what this in essence means, we have a massive globally available architecture that helps to serve your application on a global level. So when I talk about availability zones and regions, what does that mean, Darko? What's a region? What's an availability zone? Glad you asked. So a region is this geographical region, a thing. Let's say it's Dublin. Let's say it's Frankfurt. Let's say it's New York or Tokyo. So that would represent a region. And then within that region, you would have multiple availability zones. Now, availability zone is a region within a region, or a part of a region that are closely connected. They have a I don't know how many millisecond latency between each other, but they consist of one or more data centers within the given region. And this way you can have an application that's spread across multiple availability zones. And this is like the default when we talk with customers and saying, hey, I want a highly available application. Multi-AZ is the first thing you opt into, where you would split your application workload, your databases, your EC2 instances, your servers, your whatever, across multiple availability zones in the same region. This gives you, by default, a highly available system, which can be resistant if something, for example, in, let's say, one part of Frankfurt where we have availability zone C, something really bad happened, and all of a sudden, no more availability zone C. Your application is still functioning because it's available in zone A and B, but yeah, Frankfurt may have a problem. But let's say you want to do more. You want to make sure that even if Frankfurt goes away completely, your application is still there. I apologize, people from Frankfurt. I'm just making a point. Nothing against you. What if you want to do more? Well, you can actually have a multi-region application. Now, this is where things get a bit more complicated, because we're actually propagating our application across multiple regions, multiple geographies, and say, right? Where you have the same workload running across different regions, different availability zones, and all behind load balancers and all being distributed through DNS. And this is what I wanted to say before. Increase in availability also increases cost and complexity because we have a lot of things coming in. So a lot more parallel systems, a lot more network traffic, a lot more things going on, and it can be much more complex and much more costly. Let me address the complexity first. How to reduce the complexity of a system in a relatively simple way. Use infrastructure as code. By using infrastructure as code, or the ability to actually provision your infrastructure through writing them in these lovely text files called templates, you give the ability to actually have a system that's which you have a very predictable way to make changes and actually provision that infrastructure. You can provision that infrastructure through the same tools, pipeline, CI/CD, whatever you have for your normal applications. And also it gives you the ability to easily replicate, not just between production staging and development, but also replicating infrastructure between different regions, because you can use the same template to deploy the same thing in a different region. Amazing. This is kind of the thing that will help reduce the overall complexity of maintaining and running such a complex system. But why? Why would you build a multi-region active architecture? Isn't that too complex? I mean, yeah, okay, availability, that's fine, but at the end of the day, AWS never goes down, right? Right? Well, it's not just that. Let's say you have your customers which are located on the East Coast, for example, and Australia, and your application is running in Frankfurt or Paris. Latency. Latency is a thing now. We're young, we're kids. I mean, my generation is relatively young. We love everything being instant. Everything has to happen right now, this instant. 20 milliseconds can be too much. So, because we still haven't figured out how to beat the speed of the propagation of electrons, there still exists latency in the world. So there's a way to reduce this by actually deploying your architecture closer to your end users. Also, improving your availability and having disaster recovery. Let's look at this example. We have our application running in US West, so on the West Coast, and we have an application running on the East Coast. We have users both from San Francisco and from New York. Then something happens to a service on the West Coast. Something is wrong. Your application can no longer function on the West Coast. What happens now? Where your customers from San Francisco cannot access that application? Well, they can access the application in US East. Of course, a bigger latency jump, yeah, fine, but the application can still serve your end users without a problem. So this is kind of one of the things. Now, what is the prerequisite to having all of this? What is the thing we need to have a great, capable, active multi-region thing? We need to have, well, globally available, secure, reliable, global network. If you want to hear about AWS's network, which I don't have time to explain today, but a talk by James Hamilton from reInvent 2016, which was 4 years ago. Wow. Yeah, check his talk out. You can find it on YouTube. It's great. James is a distinguished engineer at AWS. Lovely guy to listen to. Check it out for sure. So you need this big, global, scalable, reliable network. And AWS has that. We invest so much into building this network, increasing its throughput and making it super secure and reliable, just because we want to be able that our customers have globally distributed applications. So we own a lot of that infrastructure. So all of those cables are owned by us. We maintain it. We make sure it works. So yeah, once you get into the AWS network, it kind of goes all through all of our backbones, which is just amazing. So let's actually go back to our multi-availability zone architecture, the defaultly highly available application on AWS. And let's talk about the costs in this case. So you saw the network, we saw the complexity, but the cost. We have 3 availability zones here. And those 3 availability zones must have multiple servers in them, right? That means we must have at least 3 copies of our application, databases, servers, whatever we have running in each of those availability zones. That can be costly. That's basically tripling your cost. So if only there was some set of services that can avoid these server costs. Well, yes, there is serverless. So the whole point of this talk is to talk about serverless services that can actually replace a bunch of these things, and they're by their nature, they should be highly available. So why serverless? Serverless, actually, I need to do this joke. Everybody does this joke when they talk about serverless. There are servers in serverless, by the way. So there are servers in serverless. It's basically just an operational model. The way you manage these things is different than a non-serverless setup. So you don't need to provision, you don't need to manage, you don't need to patch, you don't need to worry about anything like that. They're highly available and fault tolerant and automatically scalable by their design, right? Because you have these things that just keep on popping out when they need to. They should be highly available, fault tolerant, etc., etc. They should be secure. A lot of people build these things. These things have a much lower area of attack. And also, you pay only for value. Because of the nature of these services, you have almost no idle resources sitting around and doing nothing and collecting dust and not, well, costing you money at the point. Basically, you can charge per every single API call. You can drill down to your cost per API, so you can exactly know how much things cost when doing serverless. So let's talk about one more thing regarding a globally available system. And that is a problem. One of the biggest problems when it comes to a globally available system, and that's data replication. Data replication is the bane of everybody's existence. Yeah, of course, you can deploy servers across multiple regions. That's fine. I have a pipeline. I have my cloud formations. I have do all of those things. It just works. But when it comes to data, yeah, try running a MySQL cluster across multiple regions. You can, but it's not fun. Let's talk about the simplest serverless ways we can actually have data replication across the world. Number one, Amazon S3 cross-region replication. Basically, S3 buckets are where you can store objects on AWS. The simplest way you can have that cross-region or a global available S3 buckets is by enabling cross-region replication. You put a thing in one bucket and it will appear in all the subsequent buckets which are enabled on that cross-region replication. Simple as that. Very useful, very easy to get into, and well, could be very potentially important to your application. But more importantly, let's talk about that database problem. In serverless, a lot of people like to use something we like to call, well, one of our services called DynamoDB, or a NoSQL database. DynamoDB gives you the ability to actually create a thing called global tables, which gives you a fully managed, multi-master, multi-region database available through a bunch of clicks. So you don't have to worry about hosting anything, running clusters, running those things. Creating a table in one region and letting it do its thing by deploying it, well, you let itself deploy itself to other regions, and you're done. You don't have to worry about anything like that. Your application just keeps on writing to their local version of that database, increasing throughput and actually reducing latency for your application. So the simplest way you can have this globally available database is through DynamoDB tables, global tables. It works through DynamoDB table, DynamoDB streams, etc., but it's a really nice way to set it up. If we go beyond the cloud or above the cloud, what other serverless service can help us achieve global presence? DNS. DNS is one of the crucial things we need to think about when designing global systems. So you can use Route 53, which is our DNS management service, to actually route traffic between multiple regions, multiple availability zones, or multiple whatever. So you can use a bunch of different approaches to this. You can have a latency-based routing where route will be the traffic will be routed to the to the least latent version of the application, the region to your customers, right? So it will deploy them to something that's much closer to them. Geo-based routing, this is where you can actually define which customers go to which application or which region, depending on where they come from a geographic perspective. So your customers in New York will go to the application which is on the East Coast. Your customers in Seattle will go to the application which is contained on the West Coast, right? Simple as that. You can also do a round robin, which is basically going to be jumping between different regions depending on the weight you set. So you can have customers in Seattle and they would jump between US East and US West and US East. So that kind of a thing. You can also have DNS failover, which is just an amazing feature where you can have Route 53 actually run health checks on your application. And if something happens to your application, something goes wrong, for example, the application on the West Coast is gone, you remember that previous example, Route 53 will actually route all users to the application on the East Coast, and that will just work, right? But going beyond DNS, because DNS is special, right? You can actually use the AWS Global Accelerator. Now, this is a networking service that improves your availability and performance of your applications, especially applications on a global scale, by completely avoiding DNS, right? What happens here, instead of having your end users rely, like for example, on DNS routing or DNS failovers or whatnot, and going through the entire network backbone of your ISPs or a whole bunch of different hops until it reaches this AWS region somewhere far away, right? So for example, from Frankfurt, you reach Sydney. It takes a lot of time, a lot of hops. If you use Accelerator, what happens? Your end users just, as soon as they exit their ISP, they jump into the AWS backbone, and then from there, no hops, just straight to the endpoint where they want to reach. So you get, in essence, a much better performant application on a global level. Of course, this wouldn't do a lot for a single region application. It still can, but this kind of increases the speed of from a lot of your customers on a multi-region application. But okay, enough chit chat. You've been screaming at the camera, Darko, for a long time. Let's actually build something. And before I go and start banging on my keyboard, let's actually have a look at what we're going to build. The goal is to build, well, I have it already built, but I want to show you. The goal is to have a serverless application that is using its data from a DynamoDB global table, of course with Lambda functions and an API gateway as the interaction, and it's all going to be delivered through Route 53 latency routing. And in my case, I actually used not latency, but I'm going to be using the geolocation routing, right? So this demo is going to be working like we're going to try to achieve something like this, right? Multiple regions. I am actually going to use 3 regions in this case because it's serverless, it's relatively cheap. Have a global table, API gateways, and have a single URL that I'm going to be using, openconf.rup12.net, where you can access it, and depending on where you are, you're going to be pointed to a specific region. So, of course, the global table is going to sit in multiple regions. We're going to have a Lambda function that's going to serve which our business function. Our Lambda function is actually going to be our business logic. Lambda function is going to perform most of the work here. And Lambda function is going to be written in Python. What it does, it actually takes the region where it's running and writes a thing to a database in the database of its local, in its local region, and writes hello from the region the Lambda is triggered in. So at the end of the day, in the DynamoDB table, we should have multiple messages which have different, coming from different locations. So we can actually see where those messages are coming from. Finally, we have an API gateway to serve as our endpoint, where we will give it a custom domain name and point the users via Route 53 to that specific API endpoint, and well, hopefully have it work. So this should be the way it should, like looking at this, yeah, that's it. So why not let's now jump into some terminals, let's jump into some browsers and have a look how this all works. I'm actually gonna make a movie magic cut here because I need to switch to a laptop and do all of those things. So let's go into the demo. Oh, that's bad. Welcome to the demo part. Okay, so if you recall, the thing I showed you on the diagram, we're gonna have this application which is globally available with Lambda functions and DynamoDB tables and API gateways and all the things. Actually, let me show you how this works. So I guess I can do it here. So HTTP, HTTPS, openconf rup12.net/hello. If I do this, I should get output hello from EU West 1, and that's it. Because where am I? Where am I? Is in Berlin. I am currently based in Germany, right? So let's actually switch our location to Japan. Let's connect to Japan. I'm using a VPN here to connect to Japan, and in a moment or so, I should be connected. And if I do where am I should be thrown saying hello from Tokyo. Oh, I guess it's Tokyo. Hi, hey folks from Tokyo. If I do the same HTTP call that I did before, same URL, everything else, if I do this, I should get a hello from AP Northeast 1. There we go. Hello, this is a hello from AP Northeast 1. So I use Route 53 as my geographical based routing to route my application to a specific region. So let me actually disconnect from Japan. So it's going to be a bit faster to work. So if I go, for example, let's open up the browser here and go to Route 53. This is my RUP12 zone. And one of the things you will see here that is I have a couple of records here that are called openconf.rup12.net. So these records here are geolocations. So if I go to the Asia one, if I click on it and go up here to edit, one of the things that you will see here, it points to that API gateway, which is sitting in front of my Lambda function, and it is having a geolocation routing policy. And if you're coming from Asia, it's going to point you to that specific endpoint, hence having a much more better way to do it. You can also have evaluating target health. You can have a DNS failover setup. I have not set up right now, but if you enable DNS failover, if one of the region falls, if there's an issue, your request will be forwarded to the default region. For example, I can create a default record with no routing in place, and then basically Route 53 will point all of my customers to their respective regions, depending of, well, does it work or not? And if there's a problem with the health in that region, it's going to redirect them to the default one. So I have not created a default one this time just because of time, but yes, it is evaluating health. Furthermore, DynamoDB, the big important part of our application is DynamoDB. Basically having the ability to create global tables or globally available databases is important. Let's do that. Click on the big old create table button, call it openconf test1 and give the partition key. I'm going to just use ID, that should be fine. And I'm not going to use default settings because I need to have on-demand capacity for this to work. Click on demand capacity, click the create button. It takes a moment or so for the database to be created, but as soon as it's done, and it is right now, I can actually go to global tables and enable streams. You need to enable DynamoDB streams for this to work. Click on the DynamoDB streams button. It's going to create the stream, or it's going to enable the streams for this table. And then click add region and say, let's add a table, or let's add a region to my global tables. I can click Asia Pacific Tokyo. It's going to check the region to see if it is compatible. It is. Click the create replica button. Well, bam, it's all, fingers crossed, should be green. Thank you. Come on, come on. Okay, it's done. It takes a moment or so for this to replicate, so we'll see that replicas are being updated. And now I can basically, once this is done, I can add more regions, and I can basically expand it to any region available that supports global tables, right? So that's, you saw the demo, you saw how Route 53 works, but actually let me show you behind the scenes. Behind the scenes is basically just a Lambda function that is a Python Lambda function that writes to a DynamoDB table depending on where it got the request from. So this Lambda function is actually distributed to 3 regions, Tokyo, California, and Ireland. And I've deployed this application all over the place. So actually how I did that, I used infrastructure as code. So I've actually used AWS CDK to deploy my application globally. So in this case, I have CDK LS. I have 4 stacks on CDK. One deploys my DynamoDB table. It makes it globally available. And the other 3 are actually deploying my stack to California, Ireland, and Japan. So if I would like to deploy my stack, so let's say I make a change to my Lambda function, right? So I don't have the time to display this, but let's imagine we made a change to my Lambda functions. One of the things I can do here is I can go CDK deploy, and I can just do this. Japan, Ireland, California, stack, bam, and this will actually trigger a deployment right now, all of my changes across the globe, right? If I wanted to update my Lambda function, I could have done easily like this and deploy that change all over the world. And again, this is being backed by my global DynamoDB table, and the traffic is being routed through Route 53. So now, even if you go and right now and go on this URL, you will hopefully get the EU West one. Well, if you're from Greece, you should get the EU West one. But if you're somewhere else, you may either get California or you will get Ireland. So yeah, hope you enjoyed this demo. Let's quickly go back to the, oh yeah, by the way, the CDK is available on GitHub. I will be posting the link later on. It's in one of my going global with serverless repositories. It should be public by the time you see this. It is right now, but I'm gonna need to make some changes here. The link should be somewhere around here. If not, somebody will post you the link. If not, reach out to me on social media. So, okay, let's go back to the wrap up, and well, we can end this presentation. Okay, welcome back. I really hope you enjoyed that demo. Just to wrap these things up, the things I've done and a lot of things I talked about, you can actually read it on this blog post. This slide deck is going to be available to you after the fact, so don't go running around trying to type this out, but this is going to be available. I would highly suggest that you read this. Yeah, so with that being said, you've seen me today talk about how to properly deploy things on a global level to be more available, to be more to have a more reliable application, and also to do it relatively cheaply with serverless applications, and of course to reduce complexity using something like infrastructure as code to deploy all of these things for yourself. By the way, the link to the GitHub page should be somewhere here. I'm not sure. It should pop up, or it should be available to you somehow. So yeah, make sure to check that out. With that being said, my name has been Darko Meszaros. I really hope you enjoyed this presentation. I really did enjoy delivering it. Apologies to the organizers for this being a very late submission, but hey, thank you for having me here. Hope to see you sometime soon, maybe in person, maybe, who knows. Bye-bye.
All righty. Well, thank you so much. That was excellent. And I know that we'll be giving away a number of vouchers later on. So I'm sure some folks will be able to try out some of the things that you've shown us today. And that's really awesome. So thank you. It's always good to have such an engaging demo and a great presentation. Let's go to the questions. I have the first question is, do you propose to include services like this initially? Like, I'm guessing what they're saying is by design, like the multi-regional design, or do you use it only when you might need it?
So do not go overboard with anything. So I'm talking about reliability and availability. Does your application need 5 nines of availability? Think about it. If it does, absolutely. But if having just 2 nines availability is just fine, or if you do not have a customer base that's globally distributed, or you can handle a bit latency in your application, it's always fine to keep it in a single region. Again, do not be massively highly available and reliable just because it exists, because it can get very expensive.
So what you're saying is my album of kittens that I like to share on the web might not necessarily need to be available in Alaska.
Exactly. I think that would be the right way.
Okay, awesome. Fantastic. Let's go to another question then. Do you think serverless apps should be something complementary to the existing architecture and infrastructure of a business, or is it worth investing time and effort to go fully serverless?
So let me put it this way. I have a friend who runs an application that serves 5,000 different companies. It's an application that does something. It's fully serverless. Like it's a complex application that runs on multiple Lambda functions, event bridges, the whole 9 yards. Everything serverless you can imagine on AWS, it runs on. So to serve these 5,000 customers, 5,000 companies, his yearly bill is $200, right? So when we look from cost perspective to even operational perspective, it's nothing. It's peanuts. The problem with serverless now is that your monitoring, your logging, even your backups can be more expensive than running your serverless application. So while absolutely it can completely complement an existing infrastructure, and that's usually how it goes. People start augmenting their existing architectures with serverless. But hey, after a while, you start migrating things off into serverless, because at the end of the day, it's a more cost-efficient way to run anything.
Darko, I think I have a follow-on on that. You mentioned logging and troubleshooting. Okay. I have a question. How easy or difficult is it to deal with traditional problems like logging or troubleshooting when you're running serverless? So
we at AWS try to make this as easy as possible. So when it comes to troubleshooting your Lambda functions, because that's usually the first problem, like, do I have to deploy my Lambda function every time I troubleshoot it? No. There's things like SAM. I didn't show it here, but there's SAM, or the serverless application model, which helps you model your serverless applications and actually run local tests on them. So you can emulate Lambda functions and API gateways locally on your workstation with the aid of Docker. Additionally, there's the ability to do proper debugging, like the step-through debugging through Lambda functions. And when it comes to logging, we have tools such as AWS Power Tools toolkit for Lambda. Basically, it's a pluginable toolkit into your Lambda function that can easily enable logging, tracing, and everything else you need to make your to increase observability on your serverless applications. So it's relatively easy.
All right, awesome. And our final question, one of our viewers says, so if I understood it correctly, you can split your cloud, which is physically located in one area geographically, but behaving like being in another geographic area. Why was it a challenge some years ago?
So the challenge some years ago was, number one, imagine without the cloud. You would have to provision complete separate infrastructure, not to mention hosting and co-location and a whole lot of different things. That was the first initial problem you would run into if you would like to do it cross-region, cross-continent. Second thing is network connectivity. You would rely on external networking factors to make sure your application runs. You have multiple vendors of a network, multiple different hubs, multiple different things can potentially cause issues. This way, you're basically sitting on the AWS backbone, the platform built by us, maintained by us, and that it's much more much less latent, right? And especially with the advent of the cloud and things such as infrastructure as code, you've seen me there deploy my application in 3 regions with a single command, and it took 7 minutes, right? So I have the GitHub repo there. If you want to try it out, you can do it yourself. You can deploy the same application across the globe in a single command.
Fantastic. Darko, that's all the questions I have. Thank you so much for putting together a fantastic talk. I hope to see you in Athens physically, close to the Acropolis, and we're literally, 200 meters away from the Acropolis here at theCUBE today. And have a great rest of, where are you located currently?
Oh, I'm based in Berlin. Currently in Berlin, been here for 3 years now. So.
Alrighty, well, you need to make your way further south for a period as well. I'm sure the community will welcome you with open arms. Fantastic.